This video is about addition and multiplication. First, let's look at the number line. A number line shows numbers in order from negative on the left to positive on the right. And we have integers on the number line. For example, -5, -2, 0, 3, or 10. 10 will be here. We also have fractions and decimals between these integers, which we will learn a little later. What does addition mean? If I have 3 plus 1, that means I move from 3 to the right by 1 unit. I arrive at 4. What does subtraction mean? 3 minus 1. That means I start from 3 and move to the left by 1 unit. I get 2. A number and its negation are equidistant from 0. They are on the two sides of 0 with the same distance. When we talk about numbers, we hear these terminologies frequently. Positive numbers are numbers which are positive. Negative numbers are numbers that are negative. Non-negative means either positive or 0. Non-positive means either negative or 0. Positive integers are 1, 2, 3, and so on. Negative integers is -1, -2, -3, and so on. Non-negative integers starts from 0. Non-positive integers also include 0. We talk about natural numbers. Natural numbers like counting numbers, which we count using our fingers. So 1, 2, 3, and so on. Whole numbers. Usually whole numbers means integers. It's in contrast to fractions and decimals. Some people only use it for positive numbers. Strictly speaking, whole numbers should be integers. Now let's look at some properties and problems of addition. Addition is commutative. What does it mean? If I have two numbers, a and b, a plus b equals b plus a, just like 3 plus 5 equals 5 plus 3. Like I have 3 circles here, I have 5 circles over there. 3 plus 5 will be the same as adding 5 circles and 3 circles. Both are 8. Addition is also associative. What does that mean? If I have 3 numbers, I can add the first 2 numbers together, then add the third number. Or I can add the last 2 numbers together, then add the first number. For example, 2 plus 3 plus 4. I can first calculate 2 plus 3, I get 5. Then 5 plus 4 equals 9. Or I can first calculate 3 plus 4, which is 7. Then add 2, I also get 9. See, the order of addition doesn't matter. This is associative property of addition. Problem 1.3. Compute the sum 472 plus 219 plus 28. 3 numbers added together. The order of addition really doesn't matter. We can first add 219 and 28 and then add 472. However, that's going to be a little complicated. Look attentively. 472 plus 28. This is very easy to calculate. It is just 500. So we can add these 2 numbers together. We get 500. Then we add 219. So the result is 719. You see, we can add in any order, but adding in some orders may be a little simpler. We always try to find the simplest way to do the addition. Problem 1.4. Compute 2 plus 12 plus 22 plus 32 plus parentheses 8 plus 18 plus 28 plus 38. Again, 8 numbers added together. The order of addition doesn't matter. What we are going to do is we will add 2 and 38 first. We get 40. Then we add 12 and 28. We get another 40. We add 22 and 18. We get 40. We add 32 and 8. We get another 40. In total, we have 40 times 4. So the answer is 160. Problem 1.5. Find the sum 1 plus 2 plus 3 and so on plus 19 plus 20. Here, the ellipsis, this notation, means that we should include all the numbers in this pattern. And we are adding all the positive integers from 1 to 20. Now let's see what would be an easy way to find the sum. 1 plus 2 plus 3 plus and so on, plus 19 plus 20. We have 20 numbers. If we add 1 and 20, we get 21. If we add 2 and 19, we get 21. If we add 10 and 11, we also get 21. So we have 10 pairs. 21 times 10 is 210. This is one way to find the answer. Now, let me tell you a different way. Method 2. We want to calculate 1 plus 2 plus 3 plus and so on, plus 19 plus 20. We're going to rewrite this expression in a slightly different way. We write it as 20 plus 19 plus 18 plus and so on plus 2 plus 1. This is the same as the first one. Now, we're going to add these two lines together. 20 plus 1 gave us 21. 2 plus 19 gave us 21. 20 plus 1 is 21. So 2 times the sum equals 21 times the number of numbers in this series, 20. So 420. Then what is the sum we are looking for? 420 divided by 2, which is 210. The same result, different method. Adding 0. A be any number. If we add 0 to A, we get the same number A. So adding 0 doesn't change the number at all. We call 0 the identity of addition because adding it doesn't change anything. Now let's see properties and problems of multiplication. Multiplication is also commutative. If we multiply a number A by a number B, it is the same as multiplying B by A. How do we see this? For example, we have some circles here. We have 3 rows and 2 columns. So 3 times 2 equals 6 circles. And we draw another figure. We have 2 rows and 3 columns. 2 times 3 is also 6. By rearranging the circles in different ways, it doesn't change the number of circles we have. Just like 2 times 4 equals 4 times 2. Multiplication is commutative. Multiplication is also associative. If we have 3 numbers, A, B, C, multiplying the first 2 numbers together, then multiply the third number is the same as multiplying the last 2 numbers together and then multiply the first number. For example, 3 times 2 is 6. 6 times 4 is 24. 2 times 4 is 8. 3 times 8 is also 24. We get the same result. This can be understood using this figure. We have 3 rows and 2 columns of squares. In each square, we have 4 dots. Then what is the total number of dots we have? We can first count how many squares we have. So that's going to be 3 times 2, which is 6 squares. Every square, we have 4 dots. So in total, we have 24 dots. Or we can count in a different way. We count how many dots in each row. That's going to be 2 squares times 4 dots. And then we have 3 rows. So 24 dots in total. Multiplication is associative. Problem 1.9. Compute 25 times 125 times 4 times 6 times 8. 5 numbers multiplied together. If we are going to calculate 25 times 125, that will be some amount of work. Now let's see if there's any easier way to find the result. If we multiply 25 by 4, we get 100. If we multiply 125 and 8, we get 1,000. And then we have 6. So this product is 6 times 100 times 1,000, which is 600,000. This is so much easier. You see, associative property of multiplication can be very useful. Now, multiplying a number by 1 or 0. If we multiply a by 1, we get the same number. We also call 1 the identity of multiplication, or multiplicative identity. If we multiply a by 0, the whole thing becomes 0. Multiplication distributes over addition. This means that a number multiplied by a sum is the same as multiplying the number by each addend separately and then adding the products. If we have number a and b and c, a times b plus c equals a times b plus b times c. For example, I have 5 boxes of cookies. Each box has 10 cookies. My brother has 10 boxes of cookies. Each box is also 10 cookies. So altogether, we have 5 plus 10 boxes of cookies. Each box is 10. So we have 150 cookies in total. How many do I have? I have 10 times 5, which is 50. How many does he have? 10 times 10 equals 100. Altogether, 150. So it really depends on how you count. You can first count the total number of boxes together and then multiply the number of cookies in each box. Or you count how many cookies I have, how many cookies my brother has. Then we add the 2 numbers together. We should have the same result. This is the distributive property of multiplication over addition. Here is another example. 2 times 3 plus 4 is 2 times 7, which is 14. 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 is 14. Now let's see some examples. 3 plus 4 times 5, and this is 7 times 5, which is 35. Now this is a totally different thing. We first calculate 4 times 5, which is 20. Then add 3, give us 23. Now compute 51 times 9 plus 51 times 31. You can just think of it as 9 boxes of cookies plus 31 boxes of cookies. Every box has 51 cookies. So 9 copies of 51 plus 31 copies of 51. In total, that is 40 copies of 51. So this is 2040. Problem 1.14. What is the value of 17 times 13, 51 times 13, 32 times 13, added all together? So we have 17 copies of 13 plus 51 copies of 13 plus 32 copies of 13. This is 68. Add 32 is 100. So 1,300. This is the end of this video. Please work on the exercises at the end of section 1.2 and 1.3. After you're done, check your answer using the solutions book. I'll see you in the next video.